All right. This is what some of you wanted, was a video answer key to your review. So here we go. This is basically designed just to be a review on certain types of factoring. Okay, so this is just going to cover the straight up basic ones. On your quiz, expect to maybe have to do 2 or 3 different types of factoring in one problem, which is not a big deal if you know how to do all 8 types of factoring anyway. So let's just take it from 2 terms. There are 3 different ways to factor with 2 terms. You have the first one, which is difference of 2 squares. So that's just going to give us x plus 3 and x minus 3. The second one is an example of difference of cubes. So the difference of cubes would be where you first have to remember difference of cubes has a pattern. Same, opposite, plus. That's the order of which your symbols are going to go. Cube root of x cubed is x. Cube root of 8 is 2. X squared is x squared. 2 squared is 4. And the middle term is you just put those two together, multiply them. 2 times x is 2x. And that's it. You're done. Very similar is the sum of cubes. You still have your little set and your big set. So we still have same sign, opposite sign, plus. The cube root of 8x cubed is 2x. Cube root of 1 is 1. 2x squared is 4x squared. 1 squared is 1. 2x times 1 is 2x. And you are done. That's it. And finally, the last one is just prime. There is no such thing as the sum of 2 squares. There is only a difference of 2 squares. There is a sum and difference of cubes, but only a difference of squares. Now, if this was solving the difference of squares is pretty simple. Solving the sum or difference of cubes would require you to use either the quadratic formula or completing the square to solve that part of either one of these equations. That's not going to be factored again. All right, so just keep in mind, if these were equal to 0, you would have to solve, and for any sum or difference of cubes, you would have quadratic formula or completing the square to solve. 3 terms. First one is just your good old-fashioned what multiplies to a negative 3 but adds to a positive 2. And you think about that for a second, and you're going to get an x plus 3, and you're going to get an x minus 1. That'll multiply to a negative 3 but add to a positive 2, so you're done. The next one is where you're going to have to multiply those two guys together, and you're going to get a negative 30. What multiplies to a negative 30 but adds to a 13, that would be a positive 15 and a negative 2. Bring down your negative 5 and bring down your 6x squared. That's if you like doing this with splitting the middle term, also known as Batman. Factor out your GCF of a 3x, leaving you with a 2x plus 5. Factor out your negative 1, leaving you with a 2x plus 5. And your final answer is your GCFs combined and the inside of your parentheses written once. And that's it. You are good to go. Finally, the last one is basically another example of just the magic numbers, except for now you're going to have to multiply to an 8, add to a 6x squared, and it starts with an x to the 4th. It's the same thing. What multiplies to 8 and adds to 6 would be your 2 and 4, except for this would now be an x squared plus 2 and an x squared plus 4. Obviously, you see there is a good chance for some difference of 2 squares to come afterwards. All right? So those are a couple of different ways to factor with 3 terms. There are only 2 for 4 terms. The first one is grouping. That's where you just group these guys together and those guys together. Factor out your GCF of x squared, leaving you with an x plus 4. Factor out your GCF of a 9, leaving you with an x plus 4. Just like Batman, GCFs go together, so x squared plus 9. And then x plus 4, and you are good to go because that is not x squared minus 9. If that was an x squared minus 9, you would have to do the difference of 2 squares again. And then the only other one that you can factor with 4 terms right off the bat would be this guy when you have x's and then a y. or y's and then an x, or 1x and a couple of y's. It's called the 3 by 1s or 1 by 3s. So this one, we have x squared, x, and a number. So this is our cutoff right here. So this is a 3 by 1. First thing you do is factor this side. That's going to give you an x plus 3 and an x plus 3, which we can write as x plus 3 squared. And then we have our minus y squared. So you can see that this is the difference of two squares. So if we just call this a and this b, we know that a squared minus b squared would factor to a plus b and a minus b. So a is x plus 3. So our a value is x plus 3, and our b value is just the y. And then we have a minus b. Our a value again is x plus 3, and our b value is the y, except for this is minus b, so this would be a minus y. Okay, so that's just a little shortcut for this if it helps you. We would just assign a as your x plus 3, and we would assign b as our y. We don't assign a negative y because the minus is kind of in between our two different terms. Okay, so that's a way you can do a 3 by 1. Finally, the last example is something more than 4 terms. Anything more than 4 terms, you're going to have to use synthetic division of some sort. So what you would do is you would have to type this in your calculator to get a good 0 by yourself. So this would give you, first you have to do your leading coefficients. So that's going to be a 1, a negative 6, a negative 9, and a negative 27. Now, once you type it in the calculator, you're going to see that you have a couple of zeros that you can pick. And one of the first ones that's going to jump out to you is either a negative 3 or a 3. Does it matter which one you pick? Of course not. So I'm just going to pick a 3. So bring down your 1. You've got a 3. That's a 4. So this is a 12. This is a 6. So that's an 18. This is a 9. And this is a 27, which gives you no remainder. Remember, if you have a remainder, that is bad. So this is 1x cubed, 4x squared, 6x, and 9, and then you would have to try to group. But you can't group because you have a 1 and a 4 and then a 6 and a 9. If you factor out a 3 here, you're not going to be left with a 1 and a 4 on the inside, so this cannot be factored using grouping. So you type this part in the calculator, and you have to do the synthetic division again. This time you do it with a negative 3. So that would be your 1, negative 3, 1. And that would give you your negative 3. That's going to give you a 3, which is going to give you a negative 9, which means no remainder again. So your final factored form would be an x minus 3 for the first 3. And you have an x plus 3 for the negative 3 that you used. And then you have x squared plus x plus 3, which cannot be factored anymore. So you are done. That's it. So, again, on your quiz or on any test, these are just individual problems. You might have to do grouping and then a difference of two squares. You might have to do, grouping and then the sum of cubes. You might have to do grouping and then do a GCF and then do grouping. There are all sorts of different ways to do multiple types of problems. You might do one of those x to the 4th x squared problems and have a double difference of two squares. Who knows? It doesn't matter. If you know how to do each type individually, when you're done, you just keep on looking and see if something else jumps out at you as something that's factorable. If you have 2 terms, you look at one of the 3 methods that we did first. If you have 3 terms, you look for either what multiplies to this number and adds to this number, or Batman. If you have 4 terms, you look at grouping, or the 3 by 1s, which doesn't usually happen in a multi-step problem. And even more specific, if you have a synthetic division problem, I can leave you with anything when you are done. And if you think about that, you can actually do any of the above methods just using synthetic division. No one ever said it has to be done using factoring anymore, now that you know how to do synthetic division. You type this in the calculator and you get a positive 3 or a negative 3, you can synthetically divide that. Just remember that this would be a 1, 0, negative 9, because you have to have a placeholder for the x's. Okay, this would be a 1, 0, 0, negative 8. This would be an 8, 0, 0, 1. This guy right here would be a 409, but it's not factorable, so it wouldn't really matter. Nothing would work out. You can do synthetic division with Batman problems, but in this case, you would have to do it with a 1/3 or a -5/2, which means that one you probably would not synthetically divide by. But for this problem, you can synthetically divide with a -3 or a 1. So really, this is just your toolbox. You just use all these forms of factoring when you see that they come up. Writing a polynomial. This is another thing you're going to have to be able to do on your quiz. So remember, this comes from an x minus 3, this comes from an x minus 2, and this comes from an x plus 1. And then after that, you just have to FOIL twice. So the first thing you're going to do, I usually like to leave the smaller guy in front and then multiply these two. So that's going to give us an x squared, a minus x, and a minus 2. Then we're going to distribute the x to everything. That's going to give us an x cubed, a negative x squared, and a negative 2x. Now we're going to distribute the -3 to everything, which will give us a negative 3x squared, a positive 3x, and a positive 6. So then that's all just going to combine to f of x is equal to, remember you are writing a function, which means you should have some sort of equal sign in there. So f of x would do the trick. X cubed minus 4x squared plus x plus 6, and you would be good to go. In the next example, this would come from an x minus 2, but then the 3i, you have to remember, where does 3i come from? 3i comes from the square root of a -9. So which means x squared is equal to a -9, which means x squared plus 9 is what gave us our 0. So this is an x squared plus 9. And then again, you would just have to FOIL, and that would give you f of x is equal to your x cubed minus 2x squared plus 9 minus 18. All right? So that's how you write functions when you are given the solutions. One last problem, and this is everything. So, to do this one, what you should have done first is obviously sketched a graph. Because you're going to need your graphing calculator to come up with your x-intercepts or a good 0 to do your synthetic division with, because there's no way you can factor this guy from the start. What I would do is I would kind of sketch of what the graph looks like. Yes, you did have to make your y minimum go down to somewhere around -25 or something like that to be able to see everything. Right off the bat, you could have seen that this is a 0, -9. And then the only two answers that work out nice are either doing synthetic division with a -3 or a 1. So you can pick either one of those. I'm going to pick the 1. This is 1, 2, 0, 6, -9. You are never allowed to skip. So this is a 0x squared in the middle because x squared got skipped over. So bring down your 1. That's a 1. That's a 3. That's a 3. That's going to give you a 3. That's going to give you another 3. That's going to give you a 9. That's going to give you a 9. That's going to give you a smiley face. That is an x cubed plus 3x squared plus 3x plus 9. Feel free to use synthetic division again. Or you can see that this is just grouping. Factor out an x squared, leaving you with an x plus 3. Factor out your 3, leaving you with an x plus 3. So you have an x squared plus 3 and an x plus 3. And don't forget about your x minus 1 from this guy that you used in the beginning. That is completely factored. For your solutions, you already know that you have the -3 and 1. So you need 2 more because we have an x to the 4th power. So x is equal to a -3, a positive 1, and don't forget about this guy. So that means x squared is equal to a -3, which means x is equal to a plus or minus I root 3 once you solve for the x squared plus 3. All right, so that's it for that. And you cannot graph imaginary numbers, so you do not have to worry about listing those as your x-intercepts. So here are your x-intercepts. Here is your y-intercept. You'll notice that you never have a maximum, but you do have a minimum down here. His name is -1.2 .910, comma, negative 21.087 once you use the minimum feature on your graphing calculator. And for your end behavior, you can see that as x approaches negative infinity and as x approaches positive infinity, both of these are going up. So f of x is going to approach a positive infinity for both of them. And that's it. So there's a little review for you, just like some of you wanted. So now that you know what's up, make sure you are ready for your last quiz of the semester. So that's it. This is Longo and I'm out. See you, bye. Draw a smiley face on the upper right-hand corner of your quiz where you write your name. That's worth an extra credit point. Shh, don't tell anybody if they didn't hear this.